Here we go. We want to graph the functions y equals 1 over x and y equals 3 over x plus 1 minus 2. Compare the graphs. How do the numbers in the transformed function affect the shape and the position of the graph relative to the graph of the base function? So, you guys will notice I already have y equals 1 over x plotted right here in blue. What we're going to do is we're again just going to shift the crosshairs and then talk about what this graph is going to look like. So we see right here, because I have that x plus 1, that means that my vertical asymptote is going to shift 1 unit to the left, and that will give us a vertical asymptote at at x equals -1, which I just sort of toss in with that black dotted line right there. Then we see the -2. The -2 just tells us that our horizontal asymptote is going to shift 2 units downwards. And again, we just see that -2. I draw in my black dotted line right there. Now, in terms of that 3 that we see right here, that 3 kind of represents what the vertical stretch factor is going to be. When we're looking at these rational graphs, it's not quite as evident as a lot of the other polynomial functions that you've looked at, and it's just by the nature of the graph. Increasing the curvature or decreasing the curvature that we have on this hyperbola, it doesn't really always come through. So what we're going to do is we're just going to quickly look and see, well, let's find the x and y intercepts, just get 2 points that we can draw on this graph, and then we'll call it a day from right there. Looking for my y-intercept, and again, for my y-intercept, we remember that x equals 0. So I go y equals 3 over 0 plus 1 minus 2. I go y equals 3 minus 2, or I get y equals 2. So my y-intercept is going to occur at y equals 2. For my x-intercept, again, we remember that at my x-intercept, y equals 0. So I get 0 equals 3 over x plus 1 minus 2. I move the 2 over to the other side. 2 equals 3 over x plus 1. Multiply both sides by the x plus 1. And I get, with the distribution right here, 2x plus 2 equals 3. Minus the 2 from both sides, 2x equals 1, or x equals 1 over 2. So just on my graph right here in black, I'm going to shade in, well, I have that 2 right there, and at x equals 1 over 2, which is right there, we're going to have that x intercept right there. Now, just drawing my graph in like I did before, goes up, curves, and starts to approach right there. And this other piece right here, it's going to be a bit harder to sketch because we don't really have any points, but I know what the general shape of it is. Now, just so you guys can kind of see, I'm going to quickly erase what the blue one was right here, and hopefully it erases for me. There we go, and there we go. So just kind of erasing what the blue lines are, you can get a better picture of how my new graph is going to look. So what happened, our vertical asymptote shifted to be -1, or horizontal asymptote shifted to be -2, and then we had a vertical stretch by a factor of 3, which just makes the curvature a bit more steep.